All right. Yeah, sorry about the little bubble on the right. I'll blame Lee for that one. Uh, many tries. Nope. Yeah, it's like in Zoom, when you're sharing the floating thing in the middle. Thanks. But anyway, so hi everybody. Like Lee said, mentioned, my name is Roberto Hernandez, and I'm a software developer, and I like to evolve. So like Lee mentioned, I mean, I started as a C# developer way back, maybe even 1999 before it was called C#. So yeah, it's been a while. But I mean, these days I'm everywhere in terms of the cloud, AWS, the Google Cloud, Azure, etc. And a lot of my work, at least the one that I do across teams, which is not heads down development, involves doing a lot of DevOps, which I'm really passionate about. So today we're going to be talking about Bicep, which is the Azure's or part of the suite of products that Azure offers to perform infrastructure as code. So basically the heart and soul of the DevOps process of the continuous integration and continuous delivery itself. So let's get started with that. So this is the agenda of what we're going to be covering. Hopefully we'll be doing more coding than actually looking at slides, but these are some slides that actually help me more than you probably get my head in the space of what I'm talking about. So in this scenario, this presentation, we're going to be talking, again, very basic introduction to infrastructure as code, just to make sure that we all understand what it is and what our objectives are. Then we're going to be talking of infrastructure as code, specifically from the Azure perspective. There has been some form of infrastructure as code ever since the Azure cloud launch. I don't even remember when it was, but there has been several versions, some good, some bad. And Bicep is the latest one, um, latest tool of infrastructure as code that promises to be all-encompassing and easy to use. Now, the rest specific to Bicep, we're going to learn the syntax of the language. We're going to learn how to define Azure resources using the Bicep syntax. And we're going to learn best programming practices when using Bicep in every single language, right? We have things like naming conventions. We have things like code reusability, best practices when it comes to organizing our code. So we're going to touch a bit on those. And that's it. So what is infrastructure as code? And this is the Wikipedia definition. I mean, it's probably the same in all websites you visit because they reference back. So basically, infrastructure as a code is the process of managing resources in a computer data center. And notice that it doesn't mention the cloud, actually. It just mentions resources in general. And the process of managing these resources should be done either by definition files rather than extensive physical work directly on the machines. So every single solution that I've worked at some point, at least in the past, involved a 20 or 30-page manual on how to deploy the app and how to keep it running. Now, we're living in the modern era, the cloud era, the era where we don't have to go into the server room and flip a switch. And the same thing should be with our infrastructure as code. We should be able to define it in a definition file. We should be able to create it painlessly and in as little time as possible. This, of course, is part of the whole disaster recovery strategy. If for any particular reason you suffer a total loss of your resources in the cloud or in your data center, you should be able to spin it up as quickly as possible. So benefits in general, and the first one is very specific to CI/CD, eliminating drift. It says in release pipelines, but in all reality, is eliminating drift between all your environments. If you have an application that you built, and the application has the traditional space, right? Your local development environment, a dev, a stage, and or a QA. That's the proper nomenclature for it. And a production environment. Those should all be exactly the same. That way, when your application is tested in one environment, it should remain. It should not carry any bugs to any environments that are further down the pipeline. So Same thing, different terminology. Eliminate manual configuration. We're not going to go in there and click switches on and off, and enforces consistency across your environments. And that's it. That's all that I had to say about infrastructure as a code. Again, if you're not practicing it, you better get started. So, tools of infrastructure as code in Azure. I believe the one in the middle is the oldest one, Azure Resource Manager, and it probably was supported by some sort of PowerShell script, some push scripts along the line. Now, Azure Resource Manager is not a bad solution, but if you've ever seen an ARM template, you know you don't want to play with those. So ARM templates tend to be hundreds and hundreds of lines of XML. It is declarative, we'll give it that. So you're not really stating how to build your environment. You're just stating this is what you want. And that's the difference between declarative and imperative within this diagram here. When you're talking about imperative, for example, you could be talking about a batch script that you have that uses PACCLI or PowerShell scripts to build your whole infrastructure in Azure. But the problem with that is you're probably going to have to code that says if this, do that, then. So you're not really writing the state of your app. You're writing how to get there in probably a more complicated manner than it would be if you're just saying, this is what I want. So declarative solutions are the modern adaptations. Terraform is declarative. Azure ARM templates are imperative, and Azure Bicep definitely is. So I grabbed this here just because to get a quick look at an Azure template. If you've ever done Terraform, you will definitely notice that it was highly influenced by Terraform, because basically we are defining resources and assigning property to those resources. We don't do anything else. If there's a relation between those resources, for example, here there's an application plan and an app storage resource. If there's a relation between the two, it should be interpreted by the template, not defined. So again, benefits, easier syntax, and fully definition of independent modules. Now, is Bicep the right tool for you? The questions are simple. Is your team on the Azure stack completely? Then you should probably consider using Bicep as one of the tools. Is your team familiar with any other IAC tool? They could already be experts in Terraform because they have previous experience on using Terraform in any other cloud platform solution. Then maybe Bicep is not the tool for you. Are you writing a solution that is that process cloud platforms? If that is the case, then Bicep is definitely not the solution for you, because Bicep is mainly an Azure tool at this point. All the resource definitions are for resources that are defined in the Azure cloud. So hopefully that makes sense. I mean, Bicep is a very specific tool. A lot of the companies that have the solution in Azure that don't have a DevOps department could benefit from using Bicep, as it's a very simple tool to automate the deployment of their tools. And again, it's a low investment for high value in return. So how do we set up an environment for using Bicep? I would say it's exactly the same. I mean, both of the tools have a downloadable installer that you run on the fly, as long as you have the proper permissions. And yeah, at least those two, there's really no difference whatsoever. I mean, most of these tools are really simple to install because they're built in a way to run on build servers. So really, you don't want complicated installers, no next experience. It's all curl, download this component and run it off the path, basically. And it practically applies to everything that we saw in this slide. Because even ARM, I mean, ARM can be run using the Azure CLI, and those Azure CLI components can be installed off the cloud.
something like that?
So don't blame Terraform specifically for that because the thing is Azure IAC tools, including Bicep, although Bicep does a pretty good job of hiding it, are stateless. So what Terraform did in order to solve that issue is that they built a state store, and the way they promoted you should use that is by storing it in a storage. So yes, I've been there, and in those projects, you always ended up writing Terraform to build the storage containers that were going to store the state for the real project. So yeah, so but I don't blame Terraform for that. I like if you were be using, for example, Terraform and um, I have a hard time finding another solution in my mind. Maybe the natives one for AWS, like CDK or SAM. I mean, AWS has a native state support in their IAC tooling for the cloud, and all those tools benefit from it, including Terraform. So skip a step there. You can build custom modules on top of it, and those modules could be um, could depend on code, could depend on script, could depend on many things. Okay. So there might be in the future a cross-platform library of resources for Bicep. But for now, I mean, there are custom modules out there. I'll even show you later. We have a slide with a link to the repository that's an expansion and also a composition of current Bicep modules for best practices purposes. But they're all custom modules. So let's dive into this simple installation. And obviously, it's already installed in my environment. But to be fair, so this is all that needs to get done. That line of code right there. One difference though, and Bicep today, as it was, I think it was 3 years ago that it came out, maybe four, is that Bicep is part of the ACCLI tool. So you don't need to install an additional component for it to work. Usually the ACCLI already has AC Bicep in it, and it could work. You could install it independently, but I don't really see a good reason why. And I do have a sort of bash shell bias, and that's why a lot of the stuff that I'm pointing to actually is in that line. But even in Windows, it is. Hmm? No, no, no. I wouldn't do it. I wouldn't do it. Yeah. Yeah, even in Windows, I mean, nowadays, their recommendation is basically to use a Windows package manager to install it on their machine. I haven't had many instances where I've wanted to do this. If I'm working on Windows, I'm probably working on the Windows subsystem for Linux and using the Linux installer anyway. And it fits better with my work overall. This is, I guess, is mostly from my experience because a lot of the code I end up writing that it's Bicep or that it's if it's Azure, any CDK or SAM, that's going to end up running on a GitHub action. It's going to end up running on a AWS code pipeline. So those environments, the cheapest machine to get your build going through are Linux boxes. So it just makes sense. And as we know, .NET runs on Linux. Hey. So yeah, I mean, there's not much there on setting up your environment. Now we're going to go into the core Bicep syntax and features. So we're going to start writing code. And like any programming language, we're going to learn how to define our resources. It's a very simple language, of course, because we're just talking about defining resources that are going to represent resources that represent resources in Azure. Yeah, that works. But like any programming language, it's going to have variables, it's going to have parameters, and we're going to learn how to do that. It's going to have syntaxes to make things easier. So you're going to be able to write loops and conditions. So let's start with some of those demos. Let's write our first basic Bicep file. But before we get there, though, I wanted to show this script just because it emphasizes one point that I made earlier. So this is a very simple bash file that all it does is deploy a resource group and deploys a eBolt to Azure. But this is an example of imperative code to build an infrastructure. And there are many scenarios where this is actually needed in AWS or in Azure. But in Azure, it's particularly a fact that you're going to need it when you're deploying things to the subscription level or higher. Because a lot of the things that are above the subscription scope, so things like enterprise applications that need to be registered in your Enter ID, creating users in your Enter ID, are not things that you should be doing with a tool like Bicep, for example. It's Azure's opinion more than anything else. But that being said, I mean, the first thing that you learn when we start talking about Bicep, and now this machine is in the cloud. I'm trying to use it just to see if it runs a bit faster. But one of the first things that you learn when you're using Bicep is that the files that you're going to be writing run within a scope. And the scope defines what type of resources you can build. So when you're talking about subscription resources, everything that falls under that umbrella. And there's not that many things that actually fall under the umbrella of a subscription. Like things that are global to a subscription, at least off the top of my head. Front door, resource groups are the other one. And that's the list off the top of my head. It's very short. But above that, from the tenant perspective, and that's where we think it's going to grow into be a more thorough solution in the future. From the tenant perspective, that's where we define the enterprise applications that our clients use to authenticate against our Enter ID or Active Directories. And that's also where we define things like groups, users, and all that other stuff. Management group is actually all about managing permissions and the groups that manage it. I very rarely work with a customer that uses this. This is the equivalent of having the one subscription that rules them all and basically serves as your big organization way to control the access of resources. So most of our clients don't fall into that category. We work for mid to large enterprises, and they don't have, also they don't have a need for us to be in their management group also. But the default option is resource group. That's all that it is. And that's why when I came into this file, there was nothing. But I do want to show you something about this file, which is, I'm going to delete it. See, I'm a lousy Windows user. Oh, how things change. So, like all cloud providers, the definition of resources is usually very complex. So you usually end up prototyping by doing right click. You get, at some point, you're going to fall into that habit. I do so less nowadays because I have a big bank of, let's just say, code that I've already written that solves all those problems. But once in a blue moon, I run into code that I see, I say, how the hell am I going to duplicate that in Bicep? So the truth is that the best thing about Bicep is that there is a migration strategy from ARM to Bicep. And that is through the process of decompiling and compiling Bicep files into ARM. And if I go to the cloud, for example, right now, and I'll make this bigger. And I already deployed this Caperia solutions here. I'm going to be working on another name for the demos. But here, for example, I wanted to show You guys said there's an automation folder. This is for this research group called Capari 10 Dev. This folder has a storage account within it. And this storage account, I think, has 3 blob containers in it. So if I look at the export template and ignore that it says Bicep, that's new. I hadn't seen it. So yeah, you can copy the Bicep down, even better. Yes, I agree. Yeah, I agree completely. But it's good to know it's there. That's all I'm going to say. I'm just going to copy this out. Um, yeah. Oops. Come on. Yeah, in fact, the one I'm probably replacing now is simpler than the one that was there. But I'm probably getting this wrong. That's why I have readmes. Nope, close enough. So I'm basically going to take the main.json and decompile it into a Bicep file. It even gives you a couple of warnings that it's going to look bad. But when you look at it, at least the value for me is you learn a lot about that app, those resources that you right-click created that you know are working, because basically that was your development sandbox. And now you want to clean them up and automate them. In this scenario, it's a storage account, so there's not really a lot that we can learn. But as you can see, it added a bunch of properties that are not, I would say, required when I build this solution. And there are, let's see, what resources are this? The blob services, and the storages. So it does create, oh, file service. Never mind, my bad. Apparently, I don't know what I deployed. But again, this is just a straightforward process. If you have already resources in the cloud, just look at the Bicep that it produces, look at the ARM that it produces, and that's a very good starting point. We'll get to that really quickly, because again, what we have here in this scenario is a simple storage. And our second demo, I believe, is also a simple storage, but we're going to write it from scratch just to make it pretty. That being said, our third one is going to be a application website where we're deploying a Linux container out to the app service plan. And that gets complicated real quick. But let's just click on this, get a feel for what comes back. I also use, and while this is running, the concept of scope. So the subscription and the tenant scope, um, loosely, depending on the size of the app I'm building. Because sometimes if you're building a simple app, that you probably want everything on a simple resource group. And or better reason, if you're going to throw something out into the Azure marketplace, most of those apps that are actually out there actually run at the resource group scope. So that's another reason. But if you're building a more enterprise app where, let's just say, you're going to have resources spread across regions, uh, then you're probably going to want to have multiple resource groups. So that forces you to go up the scope to a subscription level. So let's Oops. Going right or first. Or first Bicep file. And this is going to be exactly like the one we just saw, but we're going to write it. It's not going to be as complex visually, at least. And we're going to be able to walk through some of these things. So optional, define the scope as resource group, define a storage account. Now, I guess I should mention, I'm using Visual Studio Code and I have the Bicep Microsoft tools installed. This is very helpful for several reasons. So you saw I'm getting IntelliSense, I'm getting guidance if my code is wrong or right. So a little bit of linting helps. So let's build a storage account. Let's pass the namespace for the resource. And this is the API schema that is going to get used to build. Same thing with the RESTful API that Microsoft exposes for building resources. This is the schema that this objects would have. They get old real quick, I gotta admit. Microsoft runs high pace on this. But yeah, a lot of help, required properties. You can see it provides me with the information right away. But let's say name for this app. Let's call it storage. Give it a location. This language supports built-in functions. If you go to the Azure Microsoft side, there's going to be a ton of them. And it also has built-in resources. So there's a function that exposes the resource group that you're deploying to. And in this case, I'm going to say deploy to the same location as the resource group. I could have also gone ahead and done the basic is US2, but most of the time, this is what we'll end up doing. Now, SKU, and like Lee mentioned, some of these properties, it's impossible to know off the top of your head of the full Microsoft offering. So getting a good list of information, let's say LRS, it is the cheaper, right? And let's just say this is a storage account. So this, we should be able, if I save it, and if I save it and I run it through Azure deploy, I should be able to get resources. But I kind of skipped something. If I deploy to a resource group, obviously I need to have that resource group created beforehand. So that's where a little bit of imperative code here will help. Now I do have some snippets just to avoid making a mistake here. So I'm going to create that Azure resource group, use this formatting, RG- passive prefix. For those of you curious, that prefix is going to be IRT for now. Now that I have that resource group created, I'm going to deploy the template that I'm building. And again, oops, that's not it. AC deployment group. Uh, it's not a specific bicep command. This would actually be the same command you would use to deploy resources with ARM, but it has the capability of receiving either bicep files or ARM files. The way I've written this is very specific. I define the name, the resource group, and the template file. But there's a little $1 at the end. And that's because I want to pass a parameter to this in certain scenarios that I will show right now. So I'm going to save this and execute this code. And this is very important. You could build, this is the thing that I'm actually going to be passing here with a $1 to this AC deployment group command. So again, I could have written it here, but I want the flexibility to pass it if I want to or not. Why? A lot of the deployment pipelines that I built have manual steps in the process where a user has to come in and approve. So it has a gate where maybe one of the senior members of the teams comes in and say, oh, the changes that Bicep is reporting, or Terraform. It's the same process actually in any stack if you're running in a what if scenario. The changes that this is reporting that it's going to be making don't affect our application in any negative way. This looks correct. So I'm just going to run this and hopefully get some information. What did I mess up? A lot of the CLIs are built so that you can rerun and be in the same state. That's why that command that I have in the top that does the creation of the research group really doesn't bark when I try to recreate it again. It really just looks that it's there, acknowledges, and moves on. Independent, what's the correct word there? It'll come to me in a bit. We're basically saying that no matter how many times we run this command, it's going to end up in the same state. Yep, that's correct. Sorry. So yeah, this ran, and we can see that this is saying, hey, I'm going to be creating a resource. A storage group is going to be out in Azure, and it's going to look fancy like this. So somebody's going to go into my deployment pipeline. It's going to say, yeah, this looks good. And we'll be able to do this. Yes, pretty much. It's built into ARM templates. That's before it trickles into Bicep in a way. Yeah.
It's Bicep will not. If someone manually goes in and makes some changes through the resource through the GUI or whatever. Will Bicep detect that? I know Terraform does, right? Because it looks at the last deployment. And it isn't like.
It'll detect the drift if you have specified it. If it's a property that's part of your template. But it won't detect any foreign extra information in it. It looks like this deployed. That's... You guys haven't noticed I'm struggling for real estate. There we have it. I do want to show you a couple of things here. And again, this applies to both. So the template that I sent should be here, but like it was mentioned before, it's probably going to be all mangled because it's going to looking at the resource as it is here. In that sense, AWS is better. Like you go to AWS and you look at the CloudFormation change set that was generated, and you see your CloudFormation template as is. What I wish to see though will be my CDK there, or my SAM, but additional things important here. This resource group, if I look at the deployments that have been done on it, I'm gonna see the deployment right there. And the way this deployment was done, I didn't include any protection. I'm gonna talk about how to protect your deployment, because there's ways even to one, either lock or prevent. There are two different things. We'll get to it. but you can either lock your resource so nobody can make changes to it, or you can define a policy that prevents changes to your resource. Probably can do the same thing with both, but they're different from an Azure perspective. And I mean, this is as simple as it comes, but let's write a little bit more things to it so that it has a bit more flavor. So there is our deployment and there are our resources. So I'm gonna add, and I guess I should show you here real quick on the storage itself. On the storage browser, if we look at the blob containers, there's none right now. So I'm just going to add a couple of blob containers to this resource just to piggyback and show you a couple of things about how to do it in Bicep. So resource, and I'm just going to call this my blobs account. Oh, it's me. Sorry about that, but it's definitely me. My apologies. So I'm going to actually reference the parent as the storage. And this is missing the name. But a couple of things that are weird here that were happening a second ago. Like if I comment this out, we're going to see that error that I was getting before. And that is because in other versions of Bicep, and it's still supported, you could actually do a slash reference to the parent resource here. So I'm not 100% that this is accurate, but something similar to this. Now, that is not recommended anymore. It's recommended that you use implicit dependencies. So also this one is explicit because we're saying that is the parent. But an explicit dependency would be, for example, if we're creating a website and we're creating a database and we're using the database.name property of the database that we created and passing it to the website. That creates a dependency that is actually discoverable by the whole process, not really implicit by us. So that is there. Let me add a single container. I think it's that one. And let's call this images. Just same sort of issue. There we go. And I believe this would work right now, but I'm going to run the what if just because I want to show you guys something. So when we create a storage in Azure, by default, it creates a blob blob account, a blob service account. So there is already a default blob service account. My code, and you can actually see it here, would actually be creating a new one. Here it is, or modifying the existing one. It actually did it correctly. So it's saying it's modifying correct the existing one, and it's changing the default values of this property. But is that what we really wanted in this case? Probably not. So one of the things that you can actually do with Bicep um, in order to solve this issue is you can say that this is an existing resource. By saying it's an existing resource, we're saying that this already exists. The name is default. This is very storage account specific, but it is always default. And now we will know that we're just trying to match to that resource, not necessarily modify it. So if I save this and run the what if again, it should be a little bit more flat. Yep. One create, no change. So yeah, as long as we're using the tool the correct way, we'll end up where we want to be. I'm going to do one more thing here, and hopefully I'll get it right. So let's see. Okay, yeah, that's fine. It's actually saying what I need to do next, which is why I was doing this, which is I'm actually going to create 5 containers now. For no reason, though, but to show you that we can loop and we can create additional resources based on parameters that are coming in down the pipeline. But of course, if I'm looping, it means that I want access to that I variable, right? In this case, it's a number, right? So it's in any language, we should also be able to interpolate, right? Simple as that. Now, if I save this, and let's just run it, see where we end up. It should create the 5 different containers within the storage account. You would think that a virtual machine that's already in the cloud would have a better pipeline. Actually, it does. But here we are. Let's see what we ended up with. So we have the storage, and let's refresh here. And there are my blob containers. So again, it's simple things, but they're worth knowing when you're learning a language. We now know how to declare resources. We now know we can loop through resources. We know we can reference existing resources. And we'll build a bit on that on the second demo, where we're actually going to talk about parameters. We're going to be talking about parameters and variables and outputs. So we're going to be able to pass information into the Bicep templates and control how the work gets done. We're going to be able to declare variables in line within the Bicep template. And that's actually one of the best practices. In the scenario that I did just now, it really doesn't, there's no need for it. But one of the things that the best practice say is use descriptive names. So if you're building a name for a resource and it's concatenated across 2 or 3 different incoming variables, it's probably better to create a variable and assign a meaningful name and then use that variable down the line. But let's go ahead and talk about the parameters. So again, this is going to be a file that is going to be in resource group scope. So might as well do it. Come on. One thing I want you guys to notice, this has changed from what I was doing in the other demo. And the only reason that I do the change is because I wanted you guys to know about this feature because it's very important. So the deployment that we're doing right now is just a deployment. The deployment that is done through the stack command is a stack and a deployment. At a stack, you can actually do additional things like deny, write, and delete. So you're basically publishing, as it comes to their infrastructure, read-only resources. Nobody's going to be able to go in, right-click, and change settings on them. It can only be done through the stack. So that's very important. And that's actually, I don't know what Microsoft doesn't have like a huge sign on their website that says, we can do this. Because I don't see anybody doing it out there, and it's actually very useful and valid in all environments. But let's go ahead. Let's keep writing some code. So some variables, and I'm gonna define the incoming parameters. So I don't think this is only me. This is probably how all deployment files end up. We always pass in some information so that we can build names that are going to be the recognizable as part of our resources. In this case, I'm passing in a prefix that's going to be used for our resources, and I'm passing in an environment type. One thing there, the allowed attribute there is going to limit the type of information that can be passed to that parameter to dev or prod. Believe it or not, that is considered a bad practice. Because a lot of the time, if you have, for example, a dev, QA, and prod, you might use this, for example, to pass values that are Azure specific, like an SKU of a product, the size of the VM, and something like that. And what Microsoft says is that, hey, that's going to be obsolete in less than a year. So using the allowed is going to force you to go change your templates if you have to change the VM type at 6 months down the road. So that's actually, at least in this scenario, probably not. But in scenarios where you're actually passing in configuration values that are tied to the Azure infrastructure, they say do not fall on this trap. So, okay, we have our parameters. And on the deploy code that was already there here, you can see that now I'm passing a dash parameters. And I have the environment type and prefix that are being passed to my Bicep file. Now, variables, why not? And here I am breaking the rules. But anyway, this variable here, really simple, just for the purpose of me trying to pass the information along that we can learn in line with the code. These are not going to cross from module to module. Every single file within that we're building on is considered a module, just as every single resource that we're building depends on a module to be built. So here, there's a unique key. I really like adding a unique suffix to my resources just because I hate it when I'm trying to deploy something out to the cloud and Azure tells me, hey, that name's being used. And that can happen in things like e-bolts, for example. It's one of the common victims. And anything that provides a unique URL based on that value with an Azure domain. So here, that unique string is going to generate a unique string based on values that are passed. And here I'm just pressing the ID of the resource group that we're actually deploying to. But I could pass additional things here. It's basically params, if you think about it from the point of view of C# function, where you can pass as many values as you want, and they're going to be considered when it comes to creating the unique string. So we have a unique key and an SKU name and tier that are going to be used for an app service that we're actually going to be building. Now, I'm going to do this the hard way, although I might come back. But let's see, Microsoft, web, server forms. And oops. Yes, that's what I forgot. But then again, I closed Visual Studio for some reason. There we are. Yeah, so server farm. Let's do them by one. This should give me the required, there it is, required properties. And concatenation, just because we're here, right? Say prefix dash. And yeah, I called it prefix, my bad, but I'm gonna add it app service plan. That's the real name there. So app service plan, move this guy away. So it's not really a prefix, my bad. But there, that's a solid name for an app service plan. Location, the same thing we did before, resource group, dot location. Now, things that I know I'm gonna need, I need to specify the kind. And this is one of those things where if you don't know the value, it's really gonna be hard to find. But that's why I recommend the Bicep tools for Visual Studio Code. Because as you can see, it's there. Like the other way I could have probably solved this and not through reading documentation is going out and doing what we did in the first demo, right? Right click the build my solution and then infer it from what I saw in those templates. But here, if I click here, this should take me out to the documentation that explains which of the ones of these options I'm going to need for what I'm going to build. So in this scenario, we're building app Linux container. Oops. And here, just going to use those variables that I already calculated. And that should be it. Although I've been bitten by this before. So I'll add that. And again, how do I know I need that? Because I've felt the pain. If you're building an app that's going to be using Docker, it needs to be a reserved instance. And that's what I'm doing here. So that's good. This should actually work. Let's build out the other resource and let's build it the easy way. I'm going to change a bit the names. As you can see, well, I'm actually using it as a prefix here. But the server farm, I called it server farm instead of app service plan. And I'm going to show you a couple of the properties that are actually here. So everything that's in here, I'm saying name, the group location. I'm saying the server farm, so I am referring to the parent. I'm saying that it should run only on HTTPS, and I'm saying in the config, name Docker registry server URL name not it. Now, these are not documented I don't want to see it anywhere. Probably we read those up that GitHub repository where we were just about a second ago. You would probably find the documentation on that. But again, in the real world, this is stuff that I prototype manually, and eventually I realized, oh, this is where Microsoft is actually dropping information about the Docker container that is going to be used when it runs my web app. So there. Now I'm going to run this so that it creates the resources. Where am I? Oh. I'm sorry?
You try sending in a variable.
Yeah, I'll,
I had seen values.
it's handy. I just don't know if it's handy for what we're doing right now. Just let's see. So I was actually going to show you what it's deploying because it is going to take a bit of time. I mean, it is running already, so we probably will see the resources. But basically, what it created is this deployment that we have right here, where it has an app service and it has an app service plan. The prefix in this was Caperia, obviously, and this is the unique ID that was generated at the end. If we look at this app service plan, just to see how things ended up, we see that the operating system is Linux. We do see from, and they move my cheese a lot here. I believe it's here. That's the problem with doing your job too well. Do you know where I can find the container, Lee? Like they moved it. I thought it was under configuration. Because like, for example, the variables that we set on the other end, like if I look here, the environment variables are here. But the settings for the container itself that say, hey, this environment is running a container and it's using that image specifically, there's a screen for it. I just, well, publishing motor container goes latest. This is editable somewhere in here. I just rarely come here anymore. I just publish. But this website, I believe I ran it earlier. Hopefully still running hot. So yeah, this is what basically got deployed if our code ran successfully, which it seems it did. Now I'm gonna answer Lee's question. Should be fun seeing it crash. Thank you. Or not. Yeah. Yeah. So before we were doing deployments, right? Where we had information what got deployed, but we also have a deployment stack. And the deployment stack, I believe, shows that information. Then I write a delete. I don't think so. Nope. We could, yeah. Like, oh, where's the other one? Did this fail? Well, there's your answer, Lee. But so this is locked, right? Mm. So we don't really have an option to do anything with it. Well, I mean, it just means you're forced to change it through the template process and the deployment process. Yeah. And the resource group is not locked. So you can delete the resource group. And the objects that we just looked at, the deployment stack, they sit under it. So if you delete that, they're gone. Yeah. But yeah, it's an interesting situation for somebody who is accustomed to going into the Azure portal and being a god, right? So you're locked out. Okay, so creating template, say, but don't modify it. Can't touch the UI, but I could delete it. Yeah. So yes, like in fact, I have the teardown scripts written here. So you can AC stack group delete. We're working with a stack. We're saying action on a manage, delete all. So you can delete it through either through the Azure CLI, and this would actually delete it too. It's because again, the resource is group is the king of all that we have deployed. So yeah. In fact, I could probably just stick with this. Yeah. Okay, so I'm sorry. Wish I had a better answer for you. Because this part, it's not really Bicep. It's always been there. Again, it's just Microsoft hasn't been very good at letting us know that it's there. But the deployment stack is basically more close to the storage that you were looking for before, the part where we can actually detect drift. We're saying here that we're creating um, I guess what will be a point in time of the deployment, and it cannot be moved either way, except through the template. Yeah. But it's really not Bicep. It's just always been there, and Bicep is benefiting from it. And again, I think Microsoft just screamed to the hills that they have this. Yes. And you can time travel, I believe, across deployments through redeployments. Yeah, but if you hear people say that Bicep and they have something that does not comply to the but I have to mention about that in a slide. Yeah, because there are organizations out there that are already thinking about that problem that you're thinking, which is I want to build secure applications where I don't want to have to think about it too much, which is the way the Azure stack works, right? You can build things that are fully open and then you start closing them down. But no, the way that, and again, I'll get that. I have that link in another slide here. there's an organization out there that is where Microsoft MVPs, person that contribute to the code base of Bicep, etc., are actually building modules that are already compliant with list privileges, with financial compliance regulations, and etc., and government compliance regulations. So there is a path ahead. It's just not all Bicep. It's people who have worked on top of Bicep to provide that for us. Yeah. Yeah. Yeah, because if Terraform doesn't have those modules, then yes, that is an advantage for Bicep. So now we're going to talk about modules. And we have been using modules. Every single resource that we define is actually using a module, like the Microsoft storage account, et cetera, et cetera. But we're now going to build modules for the purpose of organizing our code and making it more readable and reusable within our application. There are many reasons why. For example, if you're building an application, and again, you have to deploy it across multiple regions, you will want to write that code 3 times. You want to be able to say, hey, deploy this web resource as I had defined it, loop through it, and assign it to different regions, which is probably what we're going to do through the demo perspective now. I think that's, well, this is your answer, actually. This is the thing that we have right here. And this is the Azure verified modules. Failed. And again, it's an organization that solves the problem that you were talking about. I want to start from a solid starting point rather than having to build on top of it. Yeah. So let's do this. Let's write a module. I what? Yeah, I believe. Yeah, this is the last module. Because in a way, everything. What happens with this demo is that I hit a lot on the things that are at the end. I don't know why at the beginning, but yeah. So this is actually going to be the last demo, and again, it's sort of like, how do I organize my code? How am I going to write reusable code within my solutions? And this is the no modules approach. And as you can see, this got unruly pretty quick. It's still one file, and it's still less than 150 lines, but there's a lot of code there. It doesn't really tells you this is what's in here. And if you look at this, actually has a visualizer. I don't think I've showed you guys before, but this has a visualizer of the resources that are in there. Not really. Not what I wanted. I'm missing my Mac right now. I know I'm on it, but it doesn't feel like it. But yeah, like every single value there is basically, here's the server farm, here's the web app, here's the database, here's everything, etc. And my point with that, if I could show you guys, is that that's a developer's point of view of the application, right? You know all the details, you want to see it that way. But like, if you want to visualize your main Bicep and see what makes your app tick, oh, there's a database. Oh, there's a web. Oh, there's a bolt component to it. But you don't really want to see all the intricate things, at least not at this high level. And that's what we're going to accomplish here. So this is, again, the same thing we did, a bit more complex, because the demo that I ran just a second ago, the database was using SQLite running on the container. Obviously not production, but it was doing that. So at this point, we pulled it out, and now we have the Ghost container talking to a MySQL Server database that is hosted on the Azure cloud. And not complex. If you see the the definition of the MySQL server is standard. We're just telling, hey, this is the SKU for it. This is the login and password for it. And these are all generated values that only my templates know. And this is the database, etc. But again, there's a lot of parts. So I'm going to start by basically moving out the database out of this file. And what I'm going to be doing here is I'm going to be creating a db.bicep. So that db.bicep, I'm just going to go ahead and copy paste everything that's related to the database. I need a Windows mouse. There we go. And I'm going to paste that there. Okay. So a lot of red because I didn't bring in the variables. I didn't bring in the parameters. So this is a module. Each module that we're going to be building needs to be passed information from the main module. So things that are going to be needed here, and I'm actually going to steal that too, just because it makes sense to do so. Steal this values right here. It's awful. It's like I'm using a computer for the first time. Okay. Okay. Maybe I tamed the demon. So a couple of other things that need to be passed here. Like one thing I noticed, this doesn't use the environment type. It does use the unique key, so I'm gonna keep using the one that is defined on the top. It's not really a secure. It's recommending it because it probably saw the word key there, so it thinks it's a secured value. The secure thing on the parameter, since we're talking about best practices, is just saying that this will never get displayed anywhere or stored in a readable manner. So, but there we have the unique key. Other things that we're going to need. This values. Let's and I'm going to convert this to param. So if there's ever a parameter that needs to be secured, it's that one. I'm going to remove that one because it's not being referenced. But there we go. Let me see. The only one that I think is not here yet is tags. And tags is something I introduced into this demo. I haven't really talked about that, but Azure lets you tags resources. And that's one of the ways that you can actually organize and visualize your resources out in the cloud. So why not have tags? So I believe this is correct. Yep. So I'm gonna save this. And here we remove all that. I'm just gonna go ahead and add a module reference, gonna call it db.bicep. And not being very helpful, but name, let's just call it db. Gonna start complaining about all the variables that I'm not passing. So every time I complete one, it's saying, hey, it's missing prefix. Missing tags. And it's missing unique key. And there, we're good. So now we've simplified this view from a point of view of now we're not seeing all the database view within the same file. Now let's do the same thing for the app service plan and the website. Web.bicep. And a lot of this actually can be copy pasted from the file I already created. Let's just add it here. And there's this value right here that actually was a implied dependency between the SQL Server and the website itself. So I'm just going to create a variable here and call it DB server FQDN, fully qualified domain name. And and yep, that should be good. Now that module, let's call it web.bicep, name web, and I believe we can copy this out. Ooh. And the one that's missing right now, it's the DB server FQDN, but I haven't created that parameter yet. So this module that we build right here, DB Bicep, must expose the information back to the main module. And what did we learn when we were talking about parameters? That there are input and there are output parameters, right? So let's just go to that db.bicep, and by convention, those are defined on the bottom. I don't think it matters, but they're defined at the bottom. And let's call this DB server FQDN. Let's call it a string. And this is actually going to be the SQL Server properties, fully qualified domain name. Save that. Back to my main. And now I can db dot outputs, DB server if you do it. Very terraforming, right? Tell very terraforming. Okay, so what else is it complaining about? Let's see what we have. It says. Oh, okay. I can live with that. It's saying that these two things actually don't belong here anymore. And it means I removed a parameter that I shouldn't have. And okay. And I mean, this is not doing it nothing right now. I know you guys have probably seen a couple of demos I've done so far. They have outputs at the bottom in the main file. Those outputs are actually things that can be sped back to the deployment and to the stack that are created within Azure and are actually visible to us there. So if like you're creating a server, it would be nice to know the FQDN from that single point of view. And other scenarios where this will be extremely helpful, if this is actually outputting values that you're going to upload to a secret, let's say in Keybolt or something similar. But in this scenario, it doesn't really help us much. I believe that's it. And now we have just a DC bicep and a web bicep. And if I do the diagram, there should be, well, it's definitely different, right? Now we have the buckets for the web and the DB part, and we have the orientation around it. And that's the same way it would look on Azure when we deploy it. We already have a deployment of this. So if we look at this one, which is similar to what I just built. Here we see that we have the web and the DB as individual deployments within the resource group itself. And we can look at them individually. We probably can see the output parameters for the DB here. Yeah, the host name is there, the one that we passed along to the website itself. The input should be here too. And things that we don't want to see, the admin password is not there because it was marked as secure. That being said, this is probably not the best place or the proper way to pass a password around. But still, it's good to know that we could have secure strings and hide them. And I could run this, but I don't think it's worth it. It will build, but it will take quite a while. So with that, let me return to my slides. We do have a couple of additional information before they kick us out. From the point of view of infrastructure, I'm guessing that the also thing will be stored with that. I've never done it, but I like a challenge.
I feel like you should be using Terraform to make the first one, and then you use Jeffrey.
Yes. But I also think to be the data from the person.
Data, I don't know if Terraform is so much.
Yeah, it's like a state zero of the database. No, I mean, when we usually do this, we handle it with database versioning. And we have the CI process build the DDL, and the CI process also updates the DDL for that. Yeah. But it sounds doable. I mean, the backups are a resource. So why not? Why wouldn't we able to point to an existing one? I mean, we probably could. Yeah. All right. So to close things out a bit, here we have some best practices I've been mentioning along the way, but I want to make a point of them. It's like naming, like in any other languages, your variables name, your resource names, everything should be readable. Now, use comments to document as properly. That sounds weird to the comments are excuses crowd, but sometimes it's needed. Use the allowed attributes sparingly. Microsoft makes a big point of that in their documentation, believe it or not. Like, again, they don't want you to use that for values that are defined within the constraint of their infrastructure. So like I did, that is wrong. You wouldn't want to have hard-coded SKUs within your Bicep file. So common nodes, use camel case for variables and resources. I believe I did that. Use the unique functions, the unique key, unique string to generate a unique identifiers for your resources. That's actually one of the things again, I'm a .NET developer originally. For the most part, I'm probably still a better .NET developer than I'm anything else. And that's one of the things that for coming from Azure to other clouds was sort of like a culture clash for me. Because in Azure, you basically name your resources very specifically, and their conventions are very specific. But like in the AWS cloud or the Google cloud, you basically just allow them to generate the resource name for you, and the infrastructure manages it. And the unique names are just unique, period. Nobody cares. So do not embed complex expressions. I'm guilty of that in all my demos. That is that fancy old string interpolations that I did everywhere. And keep up to date with your API versions, because they do. I receive emails from Azure day by day that tell me about different API versions that are being declared obsolete every single day. Do not use depends on. That is actually something that can be used to declare dependencies. If you need it, if there's an area where the Bicep tool for some reason fails to notice that this resource A depends on resource B, then you can use a depends on, but use it as as sparingly as possible. Avoid nesting, which is counterproductive to the whole module thing that I just did, but yes. And sensitive data. Do not store your sensitive data in output or input parameters. That's what key bolts are for. And I believe that's it. I mean, I spoke a lot about the best practices I went through, so I don't really see a need to rehash them. Any additional questions? And Ben, you know where to find me.
Stay tuned for the next month. It's hard, then you might think to get in-person presenters. If anyone knows any in-person presenters or are interested in presenting, come talk to me. Otherwise, I'll start looking for virtual presenters. We got a lot more variety of content. Center, you know, technology person well. Virtual presenters speaking through a screen.
So, it's all against the bill.
Yes, that's